This is a video about proof by contradiction. Suppose we want to prove that a statement P is true. So the method of proof by contradiction, first of all, we assume that P is false. So in other words, not P, the negation of P, is true. And starting with that assumption, we then do a series of logical implications and deduce from this assumption a contradiction. And by a contradiction, we mean a statement that is clearly false. So either something that contradicts one of our assumptions, or a statement like 0 equals 1. So once we've reached our contradiction, then the only way out of this is that our initial assumption that P is false is incorrect. So therefore we can deduce that P is true. So if we look at the logic behind this, let's look at a truth table. So let's suppose that P is the statement we're trying to prove and Q is the contradiction. So what we generate is a proof of not P implies Q. So I've put down the truth values for P and Q and write down the truth values for not P implies Q. So we get true, 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 false. Now what have we shown? Well, we've generated a proof of not P implies Q, so that must be true. So this tells us it's one of the first three options, but we also know that Q is a contradiction, so Q must be false. So we must be looking at this possibility. So we've shown this is true. And so if Q is false, then we know that P is true. Okay, so that's the logic behind it. Let's now look at an example. So let's use proof by contradiction to prove that the sum of a rational and an irrational is always an irrational number. So we're going to start by assuming the statement is false. We're going to argue for a contradiction. So that means that there exists some rational number A and some irrational number B, so we're assuming A and B are real numbers here, with the sum A plus B rational. So that's the negation of the statement that we're trying to prove. So working on this assumption, we can write A as m over n, and we can write A plus B as P over Q, where here m, n, P and Q are some integers, and we're assuming the denominators n and q are non-zero. So then if we take B, which is PQ minus A, we can write that as P over Q minus M over N, and if we common denominate that, we get MP minus MQ over QN. But since NP minus MQ and QN are integers, and QN is non-zero, because Q and N are non-zero, then this tells us that B is a rational. And this contradicts our assumption that B is not rational. So this contradicts the assumption that B is irrational. And therefore, with this contradiction, we've proved that A plus B must be irrational for all A in Q and B not in Q.